Things around us move in different ways. Just take a look at this horse galloping, or the motion of celestial objects relative to one another. And there's a whole branch of science which studies this. It's called kinematics. Motion can be really complex, and a whole lot of different things can be going on. If you had to study the motion of these objects, it would be really complex, which is why we're going to start with a really simple scenario. Simplest case when studying kinematics is just motion on a straight line. While studying the simple case of motion on a straight line, some assumptions need to be made. First of all, the first assumption is just in the name. Whatever object or thing we'll be studying will be moving only on a straight line. This line can be horizontal, vertical, angled, whatever, as long as it's straight. So something like this isn't going to be studied for now. The second assumption is that the object we're observing should be a particle, or a point-like object. What does that mean, though? Well, a point-like object doesn't have any dimensions, and all of its mass is concentrated into a single point. But that doesn't really exist in real life. How many point-like particles have you ever seen? So now what? How are we going to study real objects if we can only analyze point-sized particles? Well, maybe you can pretend that some objects are point-like objects if they behave really similar. Take a feather which is dropped from a height. The air resists the feather, causing it to sway through the air as it falls. Its shape and its weight makes the effect of the air resistance on the feather way more pronounced. So clearly the dimensions and the weight of the feather are contributing to the way it moves through the air. On the other hand, take a rock with jagged edges and surfaces. If you drop it from a height, it falls in a straight line to the ground. The air does have some effect on the rock, but it doesn't cause it to change direction and sway around as it falls, like the feather. So back to the question of how to study objects that aren't point-like particles. Just because point-like particles don't exist doesn't mean that some objects don't behave like them. If the object's dimensions don't have much effect on the motion, and its path of motion can be taken close to a straight line, we can pretend that the object is a particle. This doesn't mean that the rock's shape isn't affecting the path. It is, a bit. But it's good enough for us to assume that it's a point-sized object. So thirdly, we don't care about what's causing the particle to move. So why is it going faster? Why is it slowing down? Why is it reversing in direction? None of that is going to be discussed in this topic. That's for later.